The jungle is loud with life. Cicadas scream. Something big crashes through the undergrowth. A bullet ant crawls over a mossy log and vanishes into the shadows. Then, everything around one ant goes eerily still. A single infected ant marches upward, away from the safe, shaded trails its colony has followed for generations. Its legs tremble, but it climbs anyway, up a vine, through leaves, into hotter, drier air that should kill it. It pauses, as if trying to turn around, and then something inside its head takes control. The mandibles clamp down on the underside of a leaf in a perfect death grip. The ant hangs there, frozen, jaws locked like a rusted trap. Hours later, a pale stalk erupts from the back of its skull. Days later, that stalk explodes in a cloud of spores, raining microscopic bullets onto the forest floor below, directly where healthy ants walk. This is not a scene from a zombie movie. This is real. This is happening right now in forests across the world. And the thing pulling the strings isn't a demon or an alien or a mad scientist. It's a parasite. Tonight, you will see how real animals are hijacked, hollowed out, and turned into living puppets. You'll meet mind-controlling fungi, worms that rewrite fear itself, and tiny organisms that weaponize their hosts like remote-controlled tanks. By the end of this story, you might look at your own thoughts and ask a terrifying question. Are they really yours? So, what does zombie even mean in nature? In horror movies, a zombie is a corpse that moves without a mind, driven by infection, hunger, or someone else's will. In nature, the idea is disturbingly similar, but the bodies are still very much alive. When zombie animals are mentioned, these are not dead creatures staggering around. They are living animals whose behavior has been hijacked, their muscles working, hearts beating, but their instincts and decisions quietly rewritten. Parasites do not just live in their hosts, some live through them. They turn other animals into delivery systems, bait, or vehicles, steering them toward whatever fate helps the parasite survive and reproduce. To see how that works up close, the story goes back to the rainforest, where one of the most famous zombie transformations begins with a single, unlucky ant. Okay, so how does one fungus turn an ant into a hanging corpse? Light filters through the canopy. On the ground, a line of ants moves like a living river, carrying leaves, food, and larvae. Somewhere in that crowd, one ant is already doomed, even though it looks perfectly normal. Invisible spores drift through the air and land on the ant's tough outer shell. At first, nothing changes. The ant keeps climbing, cutting, working, but the spores germinate, firing thin fungal threads into its body through tiny gaps in the armor, spreading through organs and muscle. Instead of killing the ant outright, the fungus starts to send chemical signals. Those signals interfere with the ant's nervous system, slowly breaking the link between what the ant should do and what it actually does. The ant leaves the safe, cool forest floor. It climbs higher. It stops working. At a very specific height, perfect for humidity and temperature, it bites down on a leaf edge or twig and locks its jaws in place. That precise death pose is so strong that even after the ant dies, the grip holds. Now, the fungus consumes the ant from the inside and eventually erupts as a stalk from the back of its head. When that stalk matures, it blasts new spores into the air, showering the exact paths where other ants travel. From the fungus's perspective, the ant was never a victim, just a delivery system.
So what are these parasites actually doing to the brain? Parasites do not need to understand every detail of a brain. They only need to find a few key switches: fear, movement, reward, or attraction, and flip them at the right time. By releasing special chemicals, blocking nerve signals, or physically damaging precise regions, they can nudge a host just enough to send it where it would never go on its own. A tiny push, less fear of heights, a sudden urge for water, an attraction to a smell can be enough to seal the animal's fate. It's like slipping a new line of code into the operating system of a machine. The host still runs, still moves, still looks like itself, but the program underneath has been edited. To see this in action in a completely different environment, the focus shifts from a rainforest tree to the edge of a quiet pond where a cricket is about to commit a suicide it never chose.
Wait, why would a land insect suddenly jump into water? A cricket clings to a blade of grass and sings into the night. It is a land creature. Water is dangerous. To fall into a pond is to drown. Inside its body, though, something long and coiled is waiting, a hairworm. The parasite began life in water and needs to get back there to reproduce. Trapped in a land-living insect, it's like a diver sealed in a suit on the wrong planet. The only way home is to make the host do something suicidal, jump into the water. As the worm grows, it fills the cricket's body cavity, stretching the length of the host. When it is ready to leave, something changes in the cricket's behavior. Studies on similar parasites show shifts in brain chemicals and responses to light that make their hosts seek out water instead of avoiding it. The cricket blunders toward a pond, behaving strangely. It might fall, it might launch itself directly into the water. The second it hits the surface, the worm bursts out, often several times longer than the insect itself, and swims away into its natural home, free to find a mate. The cricket often dies, but from the worm's point of view, the mission is complete. It has used a living body like a disposable escape vehicle.
So you're telling me a parasite can turn off fear? Fear is one of the most basic survival tools any animal has, and some parasites have learned to selectively silence it. The best-known case involves a tiny single-celled parasite with a big agenda and a favorite predator. A mouse is born knowing, without training, that the smell of a cat is dangerous. Even a hint of cat urine should send it bolting for cover. But when that mouse becomes infected with a parasite that can only reproduce in a cat's body, the rules change. Infected mice lose their deep instinctive terror of cat scent. Some experiments suggest they may even show curiosity toward it, drifting closer to the source instead of fleeing. The parasite forms tiny cysts in brain regions linked to fear and attraction, likely tweaking important messengers such as dopamine. The result is brutal. The mouse becomes the wrong kind of brave and wanders into a predator's reach. The cat catches and eats it, and inside the cat's gut, the parasite finally gets to reproduce. The host's fear response was not just dampened, it was repurposed.
And what about that wasp that walks a cockroach like a dog? Mind control in nature is not limited to microbes and worms. Some insects have perfected it to surgical levels of precision, and the jewel wasp is one of the most chilling examples. A female jewel wasp hunts down a cockroach, tackling it with incredible speed. First, she stings the roach's thorax to briefly paralyze the front legs. Then she does something astonishingly precise. She threads her stinger into the roach's head and injects venom directly into the brain. The venom targets centers that control spontaneous movement and motivation. The cockroach is not paralyzed, it can still walk, it just no longer wants to initiate movement on its own. Its free will has been chemically dimmed. The wasp then bites off the tips of the roach's antennae and drinks a little hemolymph, almost like checking the system. After that, she simply grabs the shortened antenna like a leash and gently leads the cockroach to a burrow. Inside, she lays an egg on the roach, seals the entrance, and leaves. Over days, the larva hatches and eats the roach's organs one by one, keeping it alive as long as possible. The roach never runs, never fights, never escapes. Its body works. Its decision-making has been turned down to zero.
Are there parasites that basically put a "eat me" sign on their hosts? Not every parasite needs complicated choreography. Some just need their host to become easier prey or a better spreader of infection, and they push behavior in that direction. Tiny crustaceans in ponds and oceans sometimes carry parasites that change their sense of safety. Instead of hiding in dark water, they start swimming higher toward the surface, where light and predators are waiting. Their movements may become more erratic, flickering like a lure. Fish infected with certain parasites can become bolder and flashier, venturing into open water and moving in ways that catch a predator's eye. A healthy animal hugs the shadows. A parasitical one behaves like a moving target. It is almost as if the parasite has hung a glowing sign over the host that says, "Dinner is here." In each case, the logic is simple. The host is a stepping stone. If being eaten or exposed helps the parasite reach its next stage, the host's instincts are expendable.
Okay, but does any of this come close to humans? This is where the story creeps a little closer to home. Humans can also carry parasites that spend long periods inside the body, and in a few cases, researchers have asked whether those organisms might gently tug on behavior. One familiar suspect is the same cat-linked parasite that manipulates mice. Many people around the world have been exposed to it, often without any obvious illness. Most live normal lives. A few studies have explored subtle shifts in risk-taking, reaction speed, or mental health patterns in infected groups, but the science is complex and still debated. Humans are not turning into classic zombies, no mindless mobs, no missing free will. Still, the idea that a microscopic passenger could nudge personality by even a fraction of a degree is enough to make anyone feel a bit less alone inside their own head. The real takeaway is not that people are secretly controlled, but that the tools parasites use, chemical signals, nerve manipulation, immune tricks, are powerful enough to matter even in a brain as complex as ours.
So is nature just one big puppet show? Nature documentaries love sweeping shots of herds, flocks, and schools of fish, but running beneath all of that beauty is a darker story, one where invisible players steer visible ones. Inside ants, fungi are quietly positioning their launch pads. Inside crickets, worms are waiting for the perfect moment to stage a watery exit. Inside mice, microscopic passengers are gently leaning on fear and curiosity. Inside cockroaches, wasp venom is turning off the urge to flee. Seen this way, the world is not just predator and prey, but puppeteer and puppet. A forest, a pond, or a city street is also a theater where small, unseen organisms direct the movements of much larger ones.
Nature does not need Hollywood monsters. It already has parasites, small, silent engineers that can reach into nervous systems and twist behavior just enough to change everything. And as long as they exist, something out there is always whispering into another creature's nervous system, turning the wheel a few degrees and sending it down a path it never would have chosen alone, creating yet another real-life zombie.